All right, welcome back. We're going to finish up our notes on 8.2. We're still looking at graphing transformations of that reciprocal function. Remember, our basic parent function was just y equals 1 over x. And then yesterday, we looked at this version of it. So we are including any stretches, compressions, or reflections, which is this a piece. We're going to consider that part of our parent function just for the ease of graphing. Then we're going to look at today any kind of horizontal translation, which we will see in the denominator position here. And then any vertical translation we will see over here on the end. Okay, so H is our left and right movement, and K is our up and down movement. So our steps for graphing these, we're going to start out looking at what kind of transformations we see. We're going to graph the parent function, and again, we're going to include that a value in there so that we get any kind of stretches, compressions, or reflections figured into our graph right away. Then we're going to plot at least 2 points on each branch. Once we have that parent function, then we can shift our points and the asymptotes based on the left, right, up, down movements. Okay, so in this case, if we just look at the first part of this, our parent function is y equals 1 divided by x. The types of transformations that we see, the plus 1 here is going to shift it left 1, and the negative 2 here is going to shift it down 2. All right, so we know what movement we have to make once we've got our parent function graphed. So let's pick a few points. Again, we only need 2 in each branch. So let's say we use negative 2, negative 1, and positive 1, positive 2. Remember, plugging a 0 in is going to give us an undefined y value. So that's where our asymptote is. If we put a negative 2 in for our x value, the y value that we get out would be 1 divided by negative 2, or negative 1/2. So negative 2, negative 1/2. Put a negative 1 in, we have 1 divided by negative 1, which is negative 1. And then if we put a positive 1 in, we get positive 1. And if we put a positive 2 in, we've got a positive 1/2. So we have 2 points on each branch. And remember, these are curved branches that approach those x and y axes. Now we want to shift them. So we said we have to move left 1 and down 2. So each of these blue dots, we're going to move left 1 and down 2. Okay, so we've moved our 4 points left 1, down 2. Now remember that the asymptotes are going to move along with your the points we've graphed. So initially we had a vertical asymptote. Let's get a dotted line in here. We had a vertical asymptote right on the y-axis, and we had a horizontal asymptote right on the x-axis. But those are going to move as well. So if we are moving left 1, then our vertical asymptote is going to move over here left 1. And if we're moving down 2, then our horizontal asymptote is going to move down 2 spaces. So you can see that our branches going through our red dots and approaching those red lines, it's going to look like that. So we have a vertical asymptote. Instead of being at 0, we went left 1. So our vertical asymptote would be at x equals negative 1, which means our domain is everything except negative 1. Our horizontal asymptote, we shifted down 2, so we have the equation y equals negative 2, which means our range would be everything except negative 2. All right, let's try a couple more. For this one, again, our parent function, we don't have any stretches or compressions because that top number there is just a 1. we can use the same points that we had in our previous example. -2, we get -1/2. -1 is -1. And then 1 and +1/2. So again, I'm just plugging these x values in as my denominator. Okay, so -2, -1/2, -1, -1, +1, 1, +2, 1/2. Okay, now for the transformations, if you see a -4 here, x -4, it means we went right 4. So our vertical asymptote is going to shift right 4 as well, and would have the equation x = 4, which means our domain is everything except that value. We can't be where the asymptote is. Our horizontal asymptote looks at any kind of vertical shift up and down. We are moving up 6, so our horizontal asymptote is going to shift up to 6. So our range will be everything except 6. All right, so let's move our dots right 4 and up 6. So right 4 and up 6. All right, and then looking at the asymptotes, we said that our horizontal asymptote, which was at 0, has moved up 6. So we're going to have a horizontal asymptote here. Let's get a different color. And then our vertical asymptote used to be at 0. We've moved it right 4. And now we can draw our graph in. It needs to approach those asymptotes without actually touching them. All right. We'll talk through this one, then I'd like you to pause the video and try it on your own. Our parent function that we're going to start with looks like that. Y equals -2 divided by x. And remember that a -2 means we have done a stretch and a reflection. So the stretch is going to pull our branches a little further from the origin, and then we're reflecting, which means we're going to be in quadrants 2 and 4 instead of quadrants 1 and 3. All right, we want to pick some x values that go into -2 nicely. So we could do -2, -1, +1, +2. For -2, we end up with a 1 for y. If we put -1 in for x, we end up with 2. If we put a +1 in, we get -2. And if we put a +2, we get -1. Okay, so those are my parent function points. -2, 1, -1, 2, 1, -2, and 2, -1. All right, I'd like you to pause the video and identify any kind of transformations left, right, up, down that we're doing and how that affects our vertical and horizontal asymptotes and our domain and range. Turn it back on when you've got those filled in. All right, checking your work. Looking at this, this means we have moved left 1. So our vertical asymptote that was right here on the x-axis, we have moved it left 1. So we're going to have an equation x equals -1, which means our domain is everything except -1. All right, so let's get our vertical asymptote drawn in. Left 1. And then we shifted horizontally. We went down 3 spaces. So our horizontal asymptote is going to shift down to y equals -3. So range would be everything except -3. All right, so those are my new asymptotes. And let's go ahead and move our dots left 1 and down 3. All right, so again, our branches should approach those asymptotes without actually touching them. All right, so all of our graphs now are going to have that same format. If we know what our A value is, we can write an equation for a transformed reciprocal function or inverse variation function. Both of the following graphs are a translation of y equals 2 divided by x. What are the equations for the functions? So if we know that we're starting with y equals 2 divided by x, we can figure out what that h and k piece need to be to get this given graph. We simply have to look at kind of the transformations that we see. So let's start with our vertical asymptote. Right now, also notice that our tick marks are going by 2's. So right now, this tick mark is over here at -3, at x equals -3. We've moved it left 3. Our horizontal asymptote, we have moved up, and again, if we think of those going by 2's, we've moved it up 4. So we need to write an equation that is going to shift our graph left 3 and up 4. To move left 3, our h value here, we need to plug a -3 in. So we have x minus -3, which means this is going to turn into x plus 3. To shift it up 4, our k value here has to be a +4. So that's the equation that would give us that given graph. Okay, go ahead and pause the video and try to do this next one. It starts with the same parent function, 2 divided by x. You just have to figure out your h and k values. Okay, let's check. For this one, it looks like, again, our tick marks are going by 2, so it looks like we moved right 1, and we shifted our horizontal one down 2. So we need to go right 1, which would mean we'd need x minus 1 in our equation, and down 2, we would need to have a -2 as our k value. All right, the last question says to write an equation for the translation of y equals 3 divided by x that has the given asymptotes. So I want you to picture x equaling -2 means we have a vertical asymptote over here at -2. Instead of being on the y-axis, we have shifted it left 2. So we need to plug a -2 in for our h value. To move left 2, if we subtract a -2, ends up being x plus 2. Y equals 5 means that we have moved up 5. So we would need to have a +5 on the end to shift our graph up 5. All right, so in summary, we have y equals a divided by x. We're going to call that our parent function. Which means it's going to account for any stretches, compressions, and reflections already in our points plotted. Then we're going to look at any kind of left or right horizontal shift and any kind of up or down vertical shift. And that's going to move asymptotes along with our points. Okay, let me know if you have any questions on these graphs.